Recall, in electrolysis, an external current drives the reaction, but the cathode reduction takes place, that is, gaining electrons. The anode oxidation takes place, that is, losing electrons. Today's question is a little subtler. Then several species are present in a solution, which one actually reacts at an electrode, and what is the product? The product depends on four things. 1. The material being electrolyzed. 2. The type of electrode used. 3. The species present and their standard electrode potentials. 4. How fast the reaction goes. An inert electrode, such as platinum or gold, does not take part in the reaction. It acts only as a source or sink for electrons. Reactive electrode takes part in the electrode reaction itself. Then more than one species can react at an electrode, they compete. Their standard electrode potential values decide which one wins. Let us start with an easy case, molten sodium chloride, that is, melted sodium chloride. Here there is no water, only two ions, the sodium ion and the chloride ion. There is no competition. But the cathode, the sodium ion gains an electron to become sodium metal. But the anode, the chloride ion loses an electron to become chlorine gas. The products are sodium metal and chlorine gas. Now dissolve sodium chloride in water. Things change. Besides the sodium ion and the chloride ion, the water supplies the hydrogen ion, the hydroxide ion, and water molecules. With so many species, there is now a contest at each electrode. One contest at the cathode, and a different contest at the anode. Let us look at each one separately. But the cathode reduction takes place. There are two options. When the sodium ion plus an electron gives sodium metal, its standard electrode potential is minus 2.71 volts. The hydrogen ion plus an electron gives half a molecule of hydrogen gas, its standard electrode potential is 0 volts. Reduction is won by the species that grabs electrons more easily, that is, the one with the higher standard electrode potential. 0 is greater than minus 2.71. The hydrogen ion wins and hydrogen gas forms. The sodium ion stays in solution. This hydrogen ion comes from water splitting into the hydrogen ion and the hydroxide ion. The net reaction at the cathode is water plus an electron gives half a molecule of hydrogen gas plus one hydroxide ion. Now the anode. Here oxidation takes place, that is, a species loses electrons. Again, two options. The chloride ion loses an electron to give chlorine gas. Its standard electrode potential is 1.36 volts. Water is oxidized to give oxygen gas. Its standard electrode potential is 1.23 volts. Oxidation is the other way around. The species that gives up electrons more easily wins, that is, the one with the lower standard electrode potential. 1.23 is less than 1.36. Go by the numbers, water should be oxidized to give oxygen gas. But there is a twist here. Bomb reactions, though allowed by the standard values, happen very slowly. To push them forward, more voltage is needed than expected. This extra voltage is called overpotential. The reaction that gives oxygen gas has a large overpotential, and it is very slow. Even though the standard values favor water, in practice it is chlorine gas that forms at the anode. This is the main lesson. But standard electrode potential values tell you which reaction is possible, but how fast the reaction goes, the kinetics, also decides the product. Let us put both electrodes together. Sodium chloride in water plus water gives the sodium ion plus the hydroxide ion plus half a molecule of hydrogen gas plus half a molecule of chlorine gas. The products are sodium hydroxide in solution, hydrogen gas, and chlorine gas. One small note. The standard electrode potential values we used are for standard conditions. To include the real concentrations, replace these values with the electrode potentials given by the Nernst equation. Recall part 6. Let us look at one last example, the electrolysis of sulphuric acid. but the anode there are two options. Water is oxidized to give oxygen gas. Its standard electrode potential is 1.23 volts. 2. The sulfate ion is oxidized to give the peroxodisulfate ion. Its standard electrode potential is 1.96 volts. Here concentration decides the product. In dilute sulphuric acid, water is oxidized and you get oxygen gas. Put in concentrated sulphuric acid, the sulfate ion is oxidized and you get the peroxodisulfate ion. Let us recap. The product of electrolysis depends on the material, the electrode, the standard electrode potentials of the species, and the speed. The cathode, the species with the higher standard electrode potential is reduced. But the anode, the species with the lower standard electrode potential is oxidized. What overpotential can change this? That is why sodium chloride in water gives chlorine instead of oxygen. Concentration can also change the product. Thanks for watching. Like and subscribe to Vidyarthi. Electrochemistry, last 12 chemistry in English.